with these review problems, since I really want to help you guys practice and review, we have time for this. I'm going to let you attempt the problem for like 2 minutes each, depending on it on your own. So let's get a piece of paper. If you don't have any, I've got some. So attempt this on your own, and about 2 minutes we'll work through the solution together. If you don't have any questions as well, just don't hesitate to ask. So let's work on the first two. And remember, expanded form is showing exactly how many ones or 10 to the 0 you have, how many tens or 10 to the first you have, how many hundreds, 10 to the second, and so on. Now with this, all of these are going to be fill in the blank just because we're working together. But we know also to be ready for things like multiple choice, right? Because you can't really type in this into the computer. So what you're going to do is you're going to write on your paper and then see which of those matches yours. And do pay attention to details. So maybe our first idea is to say, okay, well, this is 567. So I'm just going to write out 500 plus 60 plus 7. And that's true, right? But we need to go a few steps further just to show that power of base 10, because that's what helps us whenever we understand how the different bases work. So I'm just going to look at, maybe I have this written on my personal note sheet. 10 to the 0 is 1. 10 to the first is 10. 10 squared is 100. And 10 cubed is 1,000. Now in this case, I don't have any thousands, but would y'all agree I have 5 100s? So we could write that as 5 times 10 squared. And how many 10s do we have? 6. So 6 times 10 to the first, and then 7 ones. And that'd be what we were looking for in expanded form. Do you have any questions that we can answer from this kind of topic? Okay. Have we all had time to attempt the next one, or do we need? Okay, take some time. And remember, if you're unsure where to start, maybe start by saying the number in your head. That helps you realize exactly what's going on. And no, we're just starting some review. So is this number, how would we just say it out loud?
Times 10 to the power plus 3 times 10 to the third, 0 times 10 squared plus 2 times 10 to the fourth power plus 8 times 10 to the 0th power.
Perfect, that's all done. And if we were trying to get to that point, we might say, okay, this is 63,000, right? And 28. So I'm thinking I've got 6 10,000s, which you said perfectly was 6 times 10 to the 4th, 3 1,000s. And then do y'all notice the 0 in the hundreds place means you have 0 hundreds, but you've got 2 10s and 8 ones. So that's perfect. I'm going to start here. Remember, the farthest to the right is always guaranteed. We don't know how many digits there might be to the left, so we can start at the right, and that's always the ones place. So 8 times 10 to the 0, plus, move over, 2 times 10 to the first, plus, and we just keep going over. As we go over, we move the exponent up by 1. 0 times 10 squared, plus, 3 times 10 cubed, and then finally 6 times 10 to the 4th. So exactly right, well done. Now do we see the next one? I'm writing times as a x multiplication instead of a dot here, but they are the same, right? So we were just going from our numbers to theirs, but we want to be able to reverse that. So if y'all would, take a moment to think about what number this would be, translate that, and the x is the times. Now, as we're working on this, we don't have to do it all at once. We can just translate piece at a time. For instance, we know that 10 to the 0 is 1. So this is really 3 times 1. 10 to the first is 10, so this is 9 times 10. 10 to the second is 100, so that's 4 times 100. 10 cubed is 1,000, so that's 7 times 1,000. So we can just write that out. I've got 3 times 1 plus 9 times 10 plus 4 times 100 plus 7 times 1,000. So that's 7,000 plus 400 plus 90 plus 3, adding that up either mentally or my calculator, and y'all get 7,493. So how do you feel about this topic so far? Good. Any questions before we move on? Okay, great. And remember, anytime you have questions, feel free to interject. This is meant to be hopefully a helpful time for everybody. So now we're going to get to some of our historical numbers. The formula sheet will be given, but based on being given the formula sheet, you'd want to be able to identify, oh, this is the Egyptian numbers, or this is the Greek numbers, right? It's not always going to say these are Egyptian numerals, but you can tell that from the formula sheet. So just for ease of working, I've included the formula sheet here. I'll zoom in. So if y'all would translate this number. And on your personal note sheet, I might write down reminders how the systems work. Right? We have the formula sheet, but remember the Egyptians are kind of what you see is what it is. So this one we'll just translate piece at a time. We kind of look for the symbols. So we've just labeled, you see that this first one represents 10,000. And how many do we have? 2 of them. So they repeat it if they want there to be multiple. So this would be 2 10,000s or 20,000. So on my paper, I'm just writing it down piece at a time. Okay, next up, we've got 3 of these spirals, each of which are 100. So that contributes 300. And then we've got 3 of these lines, which each of which are 1. So we get 3. And now the one thing we want to watch out for is that we add it together properly to make sure the place value is right. So you can either do that carefully, realizing that the 300, this 3, since it's the third place over, is going to take the place of this 0, right? This 1, because it's in the one place, is going to take the place there. Or adding in your calculator, and we should get 20,303. Does that match everybody's work so far? Any questions? Do y'all see how if you were just doing this mentally, it might be easy to mix up, where the 0 is. So I do recommend just jotting that down briefly for consistency. Okay, so now let's go the other direction. Now we're going from our number system to theirs. Remember that the location of where you write it doesn't matter. You can repeat, stack, whatever. So as I'm working this one, it's 32,634. And just saying it helps you realize what pieces we need. So we've got a 30,000, a 2,000, a 600, a 30, and a 4. So if y'all can just mentally immediately write it out from the table, that's great. Otherwise, kind of an intermediate step if you'd like to do that as your scratch work is to say, okay, I've got 30,000 plus 2,000 plus 600 plus 30, and then plus 4. And then I've kind of broken it down into the powers of 10. So I'll need 4 ones. So 1, 2, 3, 4. 3 10s. We've got our 10 here. 1, 2, 3. 6 100s, so 6 of the spirals. 2 of the 1,000, so we've got 2 of our little flowers. And then 30,000, so 3 of the 10,000s. And remember here, it doesn't matter if I wrote my 3s like this, or if I brought this one down, right, with the Egyptian. You can move it around. It's just, do you have the right number of the right symbols? And I would look for whichever one of these is correct in the multiple choice, because this isn't something I can type in. And when y'all select the multiple choice, remember, it'd be very easy for one of these to be missing, and you think it's right, except there's one small detail. So I encourage everybody to be patient make sure you're checking each of the details are there. Any questions? Doing good? Okay, now Roman numerals have a few more rules. Before y'all get started, I do want to remind everybody that Roman numerals should be written from left to right, largest to smallest, unless you want to use the subtractive feature. So if you ever see a smaller letter written before a larger number, that means subtract the smaller from the larger that comes after it. Let's take a few minutes. As we work on this one, the first thing might be to see, is anything ever out of order? So I'm just going to go left to right and see if I've ever got a smaller numeral before another. So I've got a 100 and then a 500. So immediately that makes me think smaller before larger. This is really 400. Keep going. Then I got a 50, tens, 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 5, 1, 1. So the only thing that's out of order is this pair. So that's the only one that I have to exercise caution about. Everything else should just be read off. So if a C comes before a D, that means you take 100 away from 500. So this will be 400. And then everything else is in perfect order. So we'd say plus a 50, plus these are 3 tens, so that's plus a 30. And then here we've got a 5 and 2 ones, plus a 7. So did y'all get 400? 50 plus 30 is 80. 7. Good work, everyone. Turning our attention to the next one. Give everybody a moment to attempt the next two on their paper. Let's start with the first one. I'm first just going to check, is anything out of order? Got a 500, a 100, a 10, and then a 50. So there I see it out of order. The 10 comes before the 50. And then do we also see we have a 1 before a 5? So both of these pairs are out of order. So we'll just translate this. The D is the 500 plus a C is a 100 plus, okay. Now, when this is out of order, X coming before the 50 or 10 coming before the 50 means it's 10 minus 50. So that would be 40. And then the 1 coming before the 5 means it's 1 minus 5, which would be 4. Okay, so we should get 500 plus 100 is 600. 44 is our answer. So particularly with the Roman numerals, I think it helps at the beginning to just check, is anything out of order, because that's going to impact how you read them. Now for our next one, we want to write it as a Roman numeral, and we want to do it as efficiently as possible. So while I could express 90 by having 50 and then 4 tens, would there be a more efficient way to express the idea of 90? What do y'all think? Just take 10 away from 100. I think I heard somebody else say, right? Good. So the 200, that's just 2 100s. The 90 comes from taking a 10 away from 100, so I'm gonna have to write those out of order. And then the 5 is just by itself. So we'll say 200 is 2 C's. The 90 is an X coming before a C. And then the 5 is just the V. So remember with the Roman numerals, if it's ever something like a 90, a 9, things like that, do the X before. So let's now move on to our Chinese symbols. Let's work through the first one together, and then I'll give everybody a moment to tip the next one. Remember, the Chinese symbols are in pairs. So maybe a first good step is to just pair the ones together. If there's a single one left over, that means it's from the ones place. And then the Chinese numerals always write the multiplier, and then below it, the power of 10 it's multiplying by. So finding this symbol, this comes from 7. And do we see that it's written above the 100 symbol? So that should be read as 7 times 100. So that's representing 700. Plus, okay, our symbol here, locate this on our chart. I think we get just 5. And since it's by itself, that's just the 5 ones. So this number is 705. Y'all would translate the next one. I recommend you pair it off first, translate each pair, and then write it all together. So as we translate this, we see the first pair is 2 times 1,000, followed by 7 times 100, followed by 7 again, but this time times 10. And then finally, we've got our straggler 6, So this would be 2,000 plus 700 plus 70 plus 6, 2,776. Now we should be able to go the other direction as well. So Phil can write out the Chinese numeral for 596. Since this is 596, we know we want to show a 5 times 100, 9 times a 10, and then a 6 left by itself. And we'll stack those vertically larger to smaller. So I might start by just saying 500, 90, and then 6. So the 500 will come from 5 times 100. Okay, next up is the 90. So we'll have 90 times 6, or 9 times 10. And then finally just our leftover 6. Any questions here before we move forward? Last up, I think, before we get to our positional numbers, are the Greek numerals. So you've got 2 problems here. The first one is translating this, then translating this. So I apologize, this one I wrote kind of poorly. It should look more like this. There we would get 505. Matching the symbols. Next we see we've got a 700, followed by a 70, followed by 9. So I think we would get 779. Now let's go the other direction. If y'all wouldn't mind, take a moment to write down the symbols for 257. Okay, so one by one we find our appropriate symbols. We've got one for 200, 50, and then 7, and something like that. Now let's go to our Babylonian and Mayan symbols. This is our first at Mayan. Remember, Mayan's written top to bottom. Or sorry, the top are the highest base, the bottom is the lowest base. So if you want, you can always start at the bottom and move upwards. Think about how many sections there are within here, groupings of symbols. So here we see we've got our first group at the top, second group, bottom group. The 0 is its own group, then we've got a 6 as its own group, and then we have 4s. Now we know each of these locations corresponds to the bottom is base 1, the middle is base 20, the third is base 360. So give everybody a moment to calculate this number. Remember, you translate the symbols and then multiply by the base based on its location. So I've got 0 times base 1, plus this is a symbol for 6, times base 20 because it's in the second location, plus 4 times base 360. Multiply each of these and then add them together. So 4 times 360 is 1440. 6 times 20, I believe, is 120. 0 times 1, anything times 0 is 0. So adding these together, we should get 1560 as our answer. So for the Mayan and Babylonian, the location has an implied meaning. You take that numeral that's being represented and then multiply it by the base based on the location. Any questions here? So let's turn then to the Babylonian. Remember, the Babylonian, the first base is then the one that's farthest to the right, and then the bases increase as they go to the left. So first identify how many groupings we have, translate the symbols, multiply by the implied base. So for this, we've got three bases. Our farthest one to the left represents base 1. And this is a symbol 10, 11 times 1 plus in base 60, the second from the right, we've got the symbol 10 and then 2 1, so that's 12 times 60 plus finally in our third base, we've got 3600 and it appears 2 times because you've got the symbol for 2 represented, so 2 times 3600. Multiply these separately, add them together. When we add all those together, I believe we should get 7,931. They are, thank you. That was an error. Definitely the side ones are 10. I was just reading it wrong, so we should make that 20 times 3,600, which would change that. Thank you for correcting. Does that fix make sense to everybody? Y'all saw the error. 20 times 3,600, 72,000. And then we'll add that to the 720 and add that to the 11. So we get 72,731. Does that now match everybody's calculations? Cool. Thanks again. Great. Now let's go to our final step. The last thing was working with different bases, and we know there's 2 types of problems. Other bases to base 10, in which we employ one method, base 10 to other bases. And the key thing here is recognizing which direction we're going to. So we'll do this first one together. Do y'all see it's going 4, 2, 3, and then it says subscript 5. So I would put this in the classification where I'm going from other bases to base 10. And in that case, you just read it off and remember how we deal with bases, except now instead of 10 to the 0, 10 to the first, 10 to the second, it's 5 to the 0, 5 to the first, 5 to the second, always related to what base we're working with. So I'm going to start at the farthest to the right digit, the ones digit. Since there's a 3 there, I'm going to say that's 3 times 5. Always start with the exponent 0. Do we see why I'm using the 5? Good. And then as you go over, you just add that next digit times the base that we were mentioning, base 5, except the exponent increments by 1 as you move over. Plus 4 times 5 to the second. Now take a moment to calculate each of those individual terms, then add them together. And I believe we would get 113. So when we recognize that we're going from another base back to base 10, remember your procedure is whatever base they mentioned, that's going to be the thing that's getting the exponents. So this case was 5. You always start with the one farthest to the right, the ones place, and pair that with the base listed to 0. Adding, moving to the left, the next number paired to the next highest exponent of the base. Any questions here? Okay, why don't y'all apply the same reasoning then to our next problem? Notice in this case, we're going from base 2 to base 10. So as I work on this one, spot the beginning point farthest to the right, and it's a 1. But since it says base 2, right, that has to be paired with 2 to the 0. So I'll write to begin with 1 times 2 to the 0 plus 0 times 2 to the first plus, each time you go over to the left, you just increment the exponent of the base by 1. 1 times 2 squared plus 0 times 2 down to the third plus 1 times 2 to the fourth plus 1 times 2 to the fifth. Now, particularly for these sections, the ones with the base, you'll definitely want a simple calculator to find these. So 2 to the 0 power is just 1. That's 1 times 1. 2 to the first, that's 2. Anything to the first power is itself. But since it's multiplied by 0, do we agree those kind of go to 0? Anything multiplied by 0 goes to 0. So this also goes to 0. So I'm going to write down a 0 there, 0 here. Now 2 squared, 2 times 2, Remember, exponents are repeated multiplication, so that's just 1 times 4. 2 cubed is times 2 again, which is 8. So that's 1 times, or it would be 0 times 8, but there's none of them. So then 2 to the 4th is 16, 1 times 16. And then 2 to the 5th is 32, so we've got 1 times 32. 32 plus 16 plus 0 plus 4 plus 0 plus 1. Add those all together. Did y'all get 53? And one thing that we made note of is in base 10, it's pretty easy to write 53. But the smaller the base, the more digits your number is going to have, right? Because it needs higher exponents to get to numbers to cover up like 53. So remember what we just did is going from other bases to base 10. Now let's look at our final topic, which is starting at base 10 and going to other bases. Think about how you could recognize this as base 10 to other base. Do you see here the 77 has no superscript next to it? That's implied base 10. So you know you're given 77 in base 10, and we want it to be base 3. Give everybody a moment to try their own, then we will go through this one together. So whenever we're going from base 10 to base 3, we learned 2 methods, but I think there's generally one that we prefer. And it was kind of the second method that we learned, where we start with this upside down division box. You put the base 10 number given inside, and then outside you put the base that you're trying to go to. So in this case, we're trying to go to 3. And now you'll definitely want your calculator handy. So what you're going to do is you're going to type in your calculator 77 divided by 3. And in this case, I get 25.666 repeating. Now the thing is, we care about the 25, we care about the integer part. The decimal doesn't tell us anything specifically, except that there will be a remainder, right? So then I write down the 25 part, and then I say, you know, I wanted to get to 77. That's what we're trying to accomplish. But how close do we get? We just got 3 times 25, which is 75. So how much more do we need left over to reach our goal? Do you all agree? 2? Good. So that's our remainder of 2. And you'll see the 0.666 had nothing to do with the 2. Don't think the decimal's related. And then you just keep repeating. So next you do 3, divide it by into 25. So we have 25 divided by 3. So I'll get 8.33. The key thing is I write down the 8 and I say, how close do we get? Correct? 3 times 8 is 24, but we want to get to 25. So as y'all correctly showed, we need one remainder. So I'll write over my remainder, divide that by 3. We just keep dividing by the base we're interested in. So 8 divided by 3 gives us 2.66. So I write down the 2. 3 times 2 is 6. We wanted to get to 8. Correct, everybody? Remainder would be 2. Next, divide this by 3. And at this point, you know it's going to be a 0 next, right? Because what's outside is bigger than what's inside. If you follow the procedure, 2 divided by 3, 0.66. So I write down the 0. Now 3 times 0, anything times 0 is 0. And we wanted to get to 2. So what should my remainder be? 2, good. Once you get to the 0 stage, the remainder is always what was last in the box. So 0 with the remainder of 2. And then if you use this method, there's one final trick. Remember, you have to start from the bottom and imagine you just flip it 90 degrees. So our number is actually 2, 2, 1, 2. And then I do need to make sure I write this base 3 in words. Now, as y'all saw in the 4.2 quiz, wasn't the base already included and you just had the box where you wrote in the number? So you don't have to write this subscript on the quiz because it's already going to be included, as y'all saw with the practice. Any questions here? If you wanted to, could you check your work? Yes, you could always expand like we've just been doing and make sure this number in base 3 really is 77. So why don't y'all take a moment to convert 56 to base 2. While y'all are working, I'm going to catch up with you. Now, when we're doing the division process, if it ever comes out perfectly, we know that means the remainder is 0. A lot of these are coming out nicely. Finally, we get one that's not perfect, so this goes in 3 times. So we need to have a remainder of 1. I'll get this. Yep. Now here, I'm going to make sure that I write down the right number of 1s and 0s. So I've got 1, 1, 1, 0, 0, 0 in base 2. let's look at our final one. In our final review, we have 1844 to base 5. Let's take 2 minutes on our own and then we'll discuss this together. So with this one, we have 1844 to base 5. 1844 goes in the box, 5 outside, and we start our division and remainder process. So did y'all find 368 first? Okay, now how close does that get? We multiply 368 by 5, and we get 1844. So y'all are correct, we have a remainder of 4 left. Repeat the process. 73, 5 times 73 gets us to 365. 3 is the remainder. Keep going. 73 divided by 5 gives us 14.6. So 5 times 14 gets us to 70. So we've got another remainder of 3. Now here, did y'all get 2 times? Good, remainder 4. And then at this point, 5 does not go into 2 at all, so that's a 0. And we'd have a remainder 2. So finishing this up, we would get 2, 4, 3, 3, 4 in base 5 is how we could represent 1844 in base 10.